First of all, thanks for invitation, but sorry that I cannot be there personally because we have some family issues and I have to stay with my daughter for a few days. And moreover, our flight from Prague was cancelled 2 days ago. So there was no possibility to get there for me, even for my colleague, because I was invited, but we worked together with my colleague on a book devoted to Lexis and Lexis diagram and its role in demography. So I suppose that I'm invited because of this aspect and because of our work related to the Lexis diagram, how it is called, and it was mentioned. And for the start, I just would like to mention what's demography, but I'm pretty sure that everyone knows what's demography about. Now it's working. So just to be sure that we are talking all about the same, demography could be studied as the study of reproduction of population. So in our work, we focus on the population as a whole. We really focus on the whole population, on its size, on the general changes in the population, in changes in the structure. What's quite crucial part of demography. Currently, the hot topic is population aging, logically. So those are the issues solved in demography, and we are doing it through the study of the most important or basic demographic processes like mortality or fertility are. Migration, the process of migration is sometimes taken as more the issue of social geography. And then we studied the related processes like morbidity, that means the prevalence of some illnesses, the public health, or the intensity of marriages, and so on. Those are processes that affect the population change, but rather indirectly. However, this is what we do. What we need for our work is demographic analysis and the tools related to demographic analysis. And in demography, we usually compare the results. When we calculate some measure, we need to compare it with some other countries, with some other time dimensions or something. So we need the measures to be comparable so that we can compare it. So one of the most important part of demography is adjustment for some different structures or different features of the compared populations. And how we do it, there is an approach which is called the standardization for different age structures, for example, as I mentioned. This is not complicated at all. It's quite simple, but what we need for the standardization or for any adjustment is really a good orientation in the data, in its structure and in its detail. And for this good orientation, there is a great help and very important tool that we can use, and that's the Lexis diagram. So according to Wikipedia, we all know about it, but yeah, this is a traditional source of information, at least for our students. According to Wikipedia, the Lexis diagram is a two-dimensional diagram, what's could be taken as a fact, and it represents events that occur to individuals. This is not really the fact that's the most important. It could be used in this way, it was mentioned. However, in demography, more important is that we can use it for presentation of aggregated values, of aggregated numbers, not to illustrate the lives of individuals. When we illustrate the lives of individuals, we use the lifelines, as was mentioned, but usually we do not use it in demographic analysis because the demographic analysis is focused on the population as a whole. And then it was mentioned in Wikipedia that in some cases the lifelines could or the arrangement of the axis could be different than the traditional one. The traditional one, what we know and what is the most common probably, is this one. On the left side there is a picture that I borrowed from a book of Roland Rau devoting to visualization of mortality dynamics using the Lexis diagram. There are 3 examples of lifelines for 3 outstanding demographers. And there is the traditional way how we know the Lexis diagram today. On the horizontal axis, there is the calendar time or time of birth, or this could be the time of the event. And on the vertical axis, there is the age at the event or age of the person. This is the diagram according to Wikipedia, or an example how this could be used for individual lifelines. As I said, in demography, we usually do not work with individual lifelines and individual lives. What we study are the aggregated numbers. So for this example, those are data for Czechia for selected 2 calendar years, 2009 and 2010. In this case, we can very easily read there that 261, for example, 161 children before their first birthday died during the calendar year 2010, and they were born in the birth cohort or generation 2010. That means that they were born and died in the same year before, logically before their first birthday. However, there were in the calendar year 2010, there were 52 more children dying before their first birthday. However, they were born in the previous calendar year in the birth cohort 2009. So this is the really simple way how aggregated data are presented in the current form of the Lexis diagram, as we know it and how we work with it. And this is really important help in our work, even though it's very simple, even though there is nothing complicated there. But we can distinguish, we call it the primary sets that are those gray places, and they are defined by, for example, 1 generation, 2 calendar years, and 1 completed age, or this primary set, the more gray one, a darker gray one, is defined by 1 generation and 1 calendar year, and so on. This is important so that we know really how to construct the measures. And this is what we use for the construction of the measures, because it helps us to decide what, for example, the denominator in the measure should be, whether it's the population size at the beginning of the year or at the end of the year or in the middle of the year, and so on. So this is really helpful. The crucial question is, what's the Lexis diagram in demography for real? So I just mentioned it. Usually this is used for the presentation of aggregated numbers. It's a graphical tool, and it's really important and essential help for calculating the demographic rates or probabilities, or for the orientation of data. And sometimes based on the Lexis diagram, we can even decide about the method that we used for the analysis and so on. What's important that in this picture, in this very simple picture, we can combine 3 time dimensions. It's the calendar time, the time of the event, which is studied usually, is the age, what's also some time dimension, in fact, and it's the time of birth, the birth cohort, usually. That means the generation or the year of birth. It is really important because of this combination of 3 time dimensions, which are logically connected. And this what I just mentioned could be taken as one very important aim, or very important place where we really need the Lexis diagram in demography. And the second aim of this tool in demography, and the second usage of this diagram, is data visualization, because we can use this approach for visualization of the population dynamics, of the population trends, according to age and according to time, and we can distinguish the cohort differences, for example. And this is very useful, and it gives us more interesting inputs of the population dynamics, and it helps us really to get very good oriented in the population trends. And there could be a presentation or a speech devoted solely to population dynamics based on Lexis diagram. So the crucial question may be whether the Lexis, Wilhelm Lexis, was really the inventor of this Lexis diagram, because it's named after him. So I would like to, or my aim today is to give you some historical context, just briefly, because there was something already before Lexis. Then I will briefly introduce you the Lexis work and the development after Lexis, And at the end, I will show you, of course, some practical applications. However, as I said, this could be useful for another talk and another presentation. So there will be only a few short examples, because in our work, we devoted especially to the past and to the development of the Lexis diagram itself. So as usually at the beginning, there was a question. And the question was how it is possible to express, graphically express, the probability of some person at some age to be alive after several years, after T years. This is a question proposed by Zoyner in 1869. So that means some, if I'm counting it well, 6 years before the crucial work of Wilhelm Lexis. And he proposed the graphical solution in 3 dimensions. He used a chart using one axis for age, second axis for time of birth, and the third axis for number of survivors. So this is not really the Lexis diagram as we know it today, but it could be said it was one of the first works related to this issue. On the left side, there is the picture originally proposed by Zoyner, and on the right side, there is only the same picture, but redrawn, so maybe this is more readable. And if we can just briefly follow what's in this quite complicated picture, there is something like a birth curve. If you can see my cursor, I'm not sure of it. So hopefully you can see on the right side the birth curve. It represents a model example where the numbers of births are constant in time. There is the time axis, which is on the bottom of the graph. This is the time of birth. They are 2 time moments, A1 and A2, and they are represented with 2 numbers of births equal to P1 and P2 on the left side of the picture. And we can follow in time those initial sizes of those generations, how they are declining because of mortality, what's represented by the mortality curves. And there is the timeline that is going across the bottom of the chart. And in this specific time moment, we can see the rectangular, which is equal to C2, C1, N1, and N2, representing really the numbers or the proportion of survivors from the initial population size. It looks quite complicated, but there's really nothing complicated in it. You just need to imagine the 3 dimensions in space, or and see that, and there's nothing special really. It's something like this was visualized using the modern technology, and this is in fact the same. However, there are no constant numbers of births. The birth curve is not a straight line, but there is a decline of the numbers of births. This is for Czechia from 1950 until the 1960s, and then an increase of births during the first half of the 1970s, and decreasing numbers of survivors. This is quite, nice, maybe. For some of you, we can use it in demography. However, it is useful for a different purpose than the Lexis diagram. As I mentioned, the main purpose is to use it for construction of measures for better orientation in data. So this is quite a different purpose. However, we use this method for visualization as well. And I will come back to it. Related to Lexis diagram, probably one of the first works really devoted to the main issue to the main aim to present the structure of the data is the work published by Knepp in 1869, so still several years before Wilhelm Lexis. And in fact, in this work, for the first time, the lifelines, the individual lifelines, were introduced. However, there is no straight line representing the birth curve, the numbers of line, because this is influenced by the frequency of births. What is quite unusual and not really practical. For practical usage, this is not good when there are no straight lines in the chart. So this wave or this not straight line is really because of the frequency of births during the year, for example. However, in this type of graph, we can follow the individual lives, we can define the primary sets. As I already mentioned, this is important that we can define the primary sets, like the ways how the data are aggregated. and in what dimensions the data are aggregated for construction of the demographic measures. So this could be used, but it is not very practical because of the wave there. So there was a following work presented by Becker in 1874, and the only change is that there is really a straight line representing the time dimension of the time of birth. So this is very useful approach. We can follow the individual lifelines, we can follow the period approach to data as well as the cohort approach to data. The period and cohort approaches to data are two crucial approaches how we work with data in demography. The period approach is focused on differences in time. That means it studies the intensity of the demographic processes in particular calendar years, for example, and differences between calendar years. The cohort approach is more focused on the development in one generation and comparison with particular cohorts among them. So in this diagram, we can really read the period perspective. We can see the differences in particular columns in the graph representing calendar years, and we can follow even the cohorts. So this is very useful and very practical, and I can imagine that we can really use this approach even today. However, it's not used very often, and but however, it could be, and in our work, we redraw again this chart, and we presented how this could be used in practical usage even today. And finally, there is Wilhelm Lexis entering the scene. In the preliminary remarks of his book from 1875, Lexis mentioned that he really was inspired by the work of other authors because, as was clear, all the authors worked in the same time. However, he mentioned that he was inspired by Becker, but however, above all, in relation to him, Lexis pointed out that his approach was developed independently of Becker's work. I really like the reason why it was published 1 year later than the Becker's work. And he mentions that it was because of his move to Tartu, by the way. So Tartu is quite interesting place and very important place for the development of the Lexis diagram itself, because Lexis published it 1 year later because of the move to Tartu. In Lexis' work, there are many important points. He really proposed a specific approach, not real specific, but simplified or easier approach based on the previous works. And what's important that he focused on the approach usable for life table construction. Life tables are, again, some really basic and probably the most important tool in demographic analysis. And everything what is proposed for the construction of life tables is important, because it enables us to construct these tables and use them in practice. That means that his approach is in accordance to our current needs and the needs of the demographic analysis. Lexis was not focused on individual lifelines in his diagram, but he focused more on the aggregated numbers, what again is in the accordance to current needs or the general needs of the demographic analysis. So he focused on the sets of so-called death points or birth points. This is nothing else than the aggregated numbers of demographic events like deaths, births, or we can apply it to any other demographic events. He works with the primary sets, as I already mentioned. Those are the ways how the data could be aggregated in demography, and what's really important to know and to be oriented in for proper construction of demographic measures, even in the simplest demographic analysis. And that was logical in his time. He was focused on cohort approach to analysis because this was more natural in his time to really compare the cohorts, the generations, and to study the development of demographic measures or the intensity of demographic processes during the life of one generation, of one cohort, and then to compare the cohorts. However, the reality of 20th century, above all of the 20th century, was a bit different, and the period data were available without any problem. So currently we focus more on period approach. This is the example of Lexis' work. The original picture is on the left side, and on the right side, again, this is redrawn only. We can follow the cohort approach, as I mentioned. This is really proposed for the cohort application or application in the cohort analysis. That's why it's very easy to read the cohort differences. There are examples of two lifelines also, so that you can follow the cohorts, what are the vertical slopes or columns in the picture. However, we can follow the period approach as well, but it is more complicated. It's not a vertical or horizontal line. When it's going crosswards, then it's not so easy to read it and to get oriented there. However, Lexis was in some point also the inventor in the development of this Lexis diagram or the demographic grid, because as clearly we can see, this is not really, or Lexis was not really the first one working in this issue. So we can discuss why it is named after him. So sometimes we do not use the term Lexis diagram, but the demographic grid is the same. And Lexis was the inventor of one specific aspect. He mentioned, and that's quite logical and clear, he mentioned that in the traditional rectangular form of the diagram, the time dimensions like age, period, or cohort are not represented symmetrically. The length of the lines is not the same for all the three dimensions. It's because of the Pythagoras work. And probably you know more about it than myself. So he proposed something what is called like the equilateral diagram, and he used only the angles equal to 60 degrees. This is the result. Again, the original work is on the left side, and on the right side there is the redrawn version so that it is more readable. We can follow the cohort approach or the particular cohorts again. It is possible to use it. It is possible to define the sets of data, how the data are aggregated according to particular time dimensions. It is easy to follow the period approach in the diagram as well. We can draw the individual lifelines if necessary. So everything could be used. It's very nice for me personally. It's very nice and it's cute in demography. However, for the general demographic analysis, for the easy approach or the general approach in demography, this is equally unpractical. For period approach as well as for the cohort approach, it could be used, but when it is not strictly horizontal or vertical, then it's not so practical for orientation and for usage. However, there was a development also after Lexis. And I can mention the work of Levin 1 year later, who worked also with the equilateral version of the Lexis diagram, focused also on the cohort approach. However, there was a specific work some almost 100 years later by Roland Presa in 1960s. The current version of the Lexis diagram was presented in his work. And there was really, as I mentioned, the movement in demographic analysis from the cohort perspective to a period perspective. So during the 20th century, especially in 1960s, it was not easy to get data for the cohort approach in analysis, because the cohort approach is highly data demanding. So that's why in 20th century, and especially in the second half of the 20th century, the analysis was focused more on differences in time between particular calendar years, for example. Sorry for this timing. It was quite logical during the 1960s that the diagram was focused on the period perspective. That means that it was in accordance to the availability of the data during the 20th century, and it was in accordance to the aims of the analysis in the 20th century, because usually the aim was focused on the time trends or trends in times. That's the period perspective. So we can think about the fact whether Roland Presa in 1960s only was the inventor of the current form of the Lexis diagram or demographic grid. Not the inventor of the idea, of course, but somehow reinventor and maybe the inventor of the current form, which is currently used in practice. But maybe there could be a surprise at the end, or in fact at the beginning, because already in 1870, some 5 years before Lexis, Brache published his dissertation thesis, which is not very famous, and it was devoted to life tables and graphical representation of demographic events and processes. And in his work, he in fact proposed something what is looking like the Lexis diagram or the demographic grid. On the right side, again, there is the original, and there is the redrawn version in the middle. And if we go more into detail, what we have no time right now, we can notice that this is in fact the same version as today we are using. When I go back to the current version, there is on the right side the current version what we use right now in demographic analysis. And in the Brache's work from 1870, there is the same version, and it is only rotated by 90 degrees, but otherwise it's completely the same. So it's very easy to find there the primary sets as we are used to see them currently, as we are used to use the diagram. And in fact, this is really the same what we are using right now. So we can conclude that in 1960s, Roland Pressat just reinvented this way of presentation and the demographic grid in the current version, because originally it was really proposed many years before, so 90 years before. It's a bit different from the Lexis version of the diagram, but this is given by the fact that Lexis was focused more on cohort perspective, and Brache or Pressat are more focused on the period perspective. However, still we can use both these versions, and it depends more on the aim of our analysis, because currently also the research goes more back to the cohort analysis, because the data are available even better than during the 20th century. So we have more detailed data. So now the cohort perspective is getting more and more important. So we can use the advantage that sometimes this period perspective, which is this current version, is more available or more suitable for our aims. Sometimes the cohort perspective, as it was proposed by Lexis, could be useful, and so on. I promised you some examples related also to the second aim of the Lexis diagram, was the visualization. The visualization became quite important just from the beginning of development of this tool. I already mentioned Zoyner and his work proposed in 1869. And there were other authors. Berg in 1865, he proposed a version which is not really three-dimensional, but we can follow the 3 dimensions there as well. And the famous work from 1880 made by Perozzo, I will show you the pictures. The Berg's work is on the right side, and Perozzo's work is in the middle. This is really quite famous picture, I guess. And in fact, the principle of Lexis diagram is used there, or the demographic grid, because it was before the Lexis work. So the principle of demographic grid is used there. We can follow the same data in both pictures, where for Sweden and this is for generation 1750 to 1875, we can follow the development of births. This is redrawn using the modern technology. We can follow the development of live births, and then the decreasing numbers of survivals at higher ages. This is a very simple application of the Lexis diagram, probably the most simplest one, representing the development of mortality rates. Again, this is using the data for Czechia, for males on the right side and for females on the left side. On the horizontal axis, there is the calendar year, and on the vertical axis, there is age. And we can follow the development of the intensity of the process in time. There could be followed the improvement of mortality starting around 1990, above all, or even earlier for females. So this is quite an easy way how the Lexis diagram could be used. This is a bit more complicated approach to the same demographic tool. This is a Lexis diagram where there are all the 3 time dimensions, age, period, and cohort. However, I borrowed this picture from Timothy Rife and his personal blog devoted to visualization in demography. And he added 3 other time dimensions. It's the thanatological age, that's the age or time until death, the average time until death. Then the death cohort, it's the year of death, and the lifespan, the length of life itself. So there are, in fact, 6 dimensions in this chart. So to conclude whether Lexis was the author of the Lexis diagram or demographic grid, to be more precise, there were earlier contributions to this work before Lexis. So there were more authors. I wanted really to mention this fact that Lexis was not the only one and not the first one. However, Lexis brought there many interesting ideas. He brought there the idea of aggregated numbers and the work and the focus on aggregated numbers, the usage for live tables. This was very important. And I really like the version where he thinks about the length of particular dimensions, of particular time dimensions, how they are presented, that they should be equal. However, the equal version as was presented, it's not really usable for practical usage. However, there are some examples where this equilateral form, which is quite strange maybe for the first sight, there are some examples that it was used and it could be used, and maybe we will come back to it when I already mentioned when we get more emphasis on the cohort approach in data as well, because currently the database is so rich that it enables us to get more focused on cohort approach as well, and to combine the cohort and period approach. I just want to mention that your seminar is focused on Lexis because Lexis lived in Tartu. However, I mentioned Braše is probably the first author working with the current version of the demographic grid as we know it today and as it was reinvented by Prasad. However, personally, I don't know many information about his life, about his place of living, so I'm not sure where the seminar about Braše should be taken place or where this seminar should be organized next time. So thank you for the possibility to be here, at least in this form. Sorry for that. I really hope that there will be time in the future that we can meet anywhere or we can join some conference or some seminar. And hopefully there will be more seminars such interesting and such devoted to such interesting and nice topics like this one. If you are interested in our other works related to not only methodology in demography, you can use the QR code leading hopefully to our web page, or do not hesitate to contact me through my email anytime. If you have any questions or any proposals, I would be happy for it, because this is really something like my hobby in demography. So this is really a very nice topic and I like it. So thanks a lot for the invitation and for this chance to be here. And yeah, thank you and enjoy the rest of the seminar.
Thank you very much. Yeah, I can try to show you the audience. Yeah. Thank you. Thank you so much for the nice presentation. I think it was really important to hear about all this historical developments. We have an echo here. It's quite strange to speak. But anyway, if people have questions to Klára that they would like to ask, please let know, and we try to forward the questions to Klára. Do you have any? Yeah. We can also write the questions on Zoom if you later think of something. You know, Estonians are very quiet usually at the seminars, so we don't get many questions.
Yeah, do not hesitate to contact me anytime or in any way. I really like this topic. And of course, I do not know everything. So I would like to learn something and I would like to think about something, and do not hesitate to use my email or any other ways how to contact me.
By the way, is your book still available somewhere?
Yeah, it was published in Springer, so I guess it is available. If personally someone is interested in this work, I can maybe share it, but only personally. It's not available.
Okay, thank you very much again. And I hope you can join us also for the next presentation. But we'll now have a coffee break.
Thank you.
Kuidas paned siin mikrofoni kinni?